Hello, my name is Knut Benedict and I would like to demonstrate now the operational interface of the SAMMON planning tool based on fast time maneuvering simulation. And this is to demonstrate how it's being used for planning a maneuver. First, very simple, the basics without wind. And then I can show you how it works if we have a certain wind, which makes it more complicated. So we are in a scenario where a cruise ship is entering the port of Rostock, Warnemünde. Normally these ships have to go onto the turning basin, they have to be turned and go backwards to the berth, and this is the final berth here. And I would like to show how it's working with this tool to make a concept of a sort of maneuver. First I enlarge the picture a little bit, so here's the scale. Maybe this might be sufficient, maybe a little bit more zooming in, so this might be good. So we are here now and we are proceeding for the time being with the speed of about 5.5 knots. The water depth is here about 14.5 meters. And the question is, when I arrive here at the turning basin, I have to stop the ship. And because here are some other berths, and so we need to go until here to stop the ship and to turn the ship. The first is we have to move the ship up to here. For this reason, we use the prediction. So now the prediction, every shape is representing the ship's position after up to 6 minutes. We can also enlarge it up to 24 minutes, but 6 minutes might be nice here. And the software is calculating constantly the maneuvering behavior according to this input. So if I move, for instance, the engine order astern, then the ship is going much more slower. If I do it with about 30, then it's going a little bit faster. So the first question is, or first task is to move the ship until maybe to these buoys. And the time slider is being used, as you see here, to move the ship along the already calculated track, maybe until here. And there we have to stop the vessel. So first we set a so-called maneuvering point, add maneuvering point. And then the focus of the handles is adjusted to this position. And we have to stop the vessel. So the question is, will the ship being stopped with maybe only stop, or do we have to reverse the engines to really stop the ship until before crashing into this part? So we first go to 10, this is now to 0, minus 10, so we reverse the engine, okay. So 30% astern of the full engine might be fine. So we move the ship until the position where the ship has to be stopped, like this for instance. Then we see, okay, here the ship is nearly dead in water, so only 1 knot ahead. We move a little bit further up, so it's 0.66. Okay, I say here I to the next maneuvering point because we don't want to pull the ship back, so we say, okay, it's now to be stopped, and we need to turn the ship, maybe only with bow thrusters, if you use a bow thruster like this, or even the stern thruster to the other side. This might be an option to turn the ship here at this position and move again the ship forward onto these paths. So again, so this might be suitable to speed it up a little bit and to steer the ship into the next position. So add the next maneuvering point, and now we stop the thrusters to see what happens. So double click means set to 0, and we need to speed up the engine a little bit to do it in this way. So what we see is we have to use the thruster or instead maybe the rudder to line her up and to steer the ship into the next, to steer the ship astern. Maybe we could use also 8 minutes prediction or even 10 minutes prediction. So we see this is a forecast and we move the ship with this rudder and this thruster maybe up to here. This might be the next position to line her up and to set a new maneuvering point here. Sorry, at a maneuvering point, and then we are here. So we need to put the rudder to midships and to stop the thrusters. So this might be a good situation, maybe to steer the ship and line her up into the fairway to be steered to the berthing maneuver. It's only to explain the principle. But what happens if we have more strong wind? Maybe wind with from this direction and blowing with about 25 knots. What happens then? And we start that from scratch. That means we could edit the maneuver. So I go to select and edit the maneuver. I go to position number 0. This is the initial position which we had, but the maneuver is still there. What would happen if we do the same maneuvering procedures under 60 degree of wind impact and a wind, let's say 5, we said. 25, enter, and the question is, if you start wind here, should it be also due for the other points? If you say yes, then and hit the button, then you see, okay, this would be the same maneuvering commands with the wind. It would not help. So the first we should do is we skip all the remaining maneuvering points and start again. So clear up, following, and now we are here again. What we see is that the ship is drifting. So what would be better? We change at this position the heading. Maybe we have now 6-1. We go maybe to a heading of 155 maybe. 155. Enter, and you see, okay, this might be quite good. So 6 degree of drift angle against the wind, and so we might be able to steer the ship up to this point, and then we stop the engine. So we set a maneuvering point again, and then we are here. If we stop the engine, then what would happen? In the previous maneuver it worked. So we went to minus 30, but here you see immediately this won't work, because due to the tough wind, the ship is drifting in this direction. So we need some counteraction. The first idea would be, okay, let's only using the rudder. This won't help. So no chance to help with the rudder. The other option would be maybe to split the engine. That would be a good concept. So synchronize the engine order, desynchronize, and then we could speed this engine a little bit up. Then we see, okay, so we can at least maintain the ship against the wind. It's not drifting away. And maybe we use a bow thrust a little bit additionally. So we see what happens. Bow thruster will be able to turn the ship. If we reduce this engine a little bit, then we go not that far into the wind. So with 60% bow thruster, and we could even split the engine a little bit more. And this way, this is going a little bit ahead, and this is going a little bit astern. Then you see what happens. This is the learning about how could, it's not important if it's now 30-degree rudder or 31 or 25 or so. It's only to see what the impact is of splitting the engine concept, a little bit thruster and rudder. So we go and move the ship up to here. So now we are going to putting the stern. So this might be a good position here to stop the planning here, and then we are seeing what happens. So at least we should not go with this engine astern. We don't use the rudder at this, put the rudder midship. We reduce the thruster to 0. And then you see, okay, it might work, maybe a little bit rudder to the other side. And then we can clearly steer the ship into that position. Maybe even using the thruster a little bit, also against the wind, like this. And you see, okay, we can use this opportunity to accelerate the ship here, like this, and bring it into this position. So we see, okay, the speed vector is already pointing into the channel on the reverse track. So like this, maybe. And then we set a new maneuvering point, like this. Sorry, I hit the wrong button. And then we are here. And this is a position where we could clearly steer now straight into the channel. So no thruster anymore necessary. The rudder is not being used that strong, so maybe only a little bit to this side. So you can tweak a little bit around that to really adjust the correct rudder. Because we have strong wind, you see the wind is blowing with 25 knots from this direction. Normally the passage is only possible with a drift angle, what you can see here, so it's just suitable to be accommodated into the channel, and also with a certain rudder. You should not be upset that here you have to use maybe 5.2 or 5.6 or 6 or 7 degrees. It is the average rudder angle you will be using along this channel if you have this strong wind. So then you see what if you use the slider to bring her up to this position. So this could be maybe the next position for a maneuvering point, where we now go into the final part to stop her and so we have to decrease. We have now 6 knots, nearly 7, which is not good for this channel. Normally it's allowed only 6.5 knots. But if we reduce now the engine, then you see, okay, we are just closing into the berth, and the remaining speed here would be only 5 knots. No, we should not go that close, because we have to stop her. Maybe here, and this would be the position, because we want to stop the ship here, to berth the ship here. This is the position where we should stop the vessel. So we add a maneuvering point, and then you see if we reduce the engine now, then the ship is going up to this position. So the final concept would be to go here, then and to use all maybe up to here. This could be a strong point for maneuver. We still have 2 knots, but here we can really stop her more consistently. We work with the thrusters against the wind, with both thrusters, and then you see that we can stop her dead in the water up to this position. So it should only explain the principle. We don't want to tweak all the commands very precisely. It's only to see what the different control settings have for an effect. The good thing is we can save this maneuvering plan here, for instance. We can save it under a name, and if it's saved, then we can recall it again to edit this maneuver, as we did before for the no wind difference. So this is only to explain the principle of that. So if I want to load another maneuver, for instance, then first I have to reset the maneuver, then we are here again, and then we go into the same menu, load, edit maneuvering plan. For instance, I have another version of this maneuver. We can open it, and then immediately it will be shown what the concept of the previous maneuver was. So this was the little bit different approach which I have chosen during the line. So we turned a little bit more to the wind, and if you want to edit this one, you click onto any of these positions and then you can change something. This should explain the principle of the maneuvering planning. The good thing is you can go along each maneuver if you want to brief your crew for the next maneuver for a port arrival. Then you can develop this concept beforehand. It takes 10 or 20 minutes, and you can even do different wind conditions or whatsoever current conditions and do various concepts until you arrive at a position. This is the best version, and then you can brief your crew, and even for pilot discussion. So you can, for instance, use every point. Let's say we go to point number 1, then we can see immediately, okay, what we did here. So the engine were split, and the rudder was used 17 degrees in this situation, and then the ship is being turned, and so you can hop from position to position to explain the maneuvering concept to your crew. Okay, this is one example to explain maneuvering planning. You will see also another one where we have the planning under current, and finally we will also show a demonstration how this plan can be used in the process of conning the ship, maybe by the co-nav, and it will be shown together with a very sophisticated dynamic prediction of the vessel. Okay, this should close this session. Thank you very much.